as the reverse to the distributive property. In the distributive property, one is multiplying a certain factor on the outside to everything on the inside, right? So here we have 5x squared, and these arrows should be at the 5x squared, but they got shifted. And you distribute it into the 4x form, distribute it into the 3, it should be like this. Oh, goodness, where was that? Okay. So instead of distributing it in, what we're going to do is we're going to start out with this full term, and we're going to figure out what can we take out. So it's just the opposite of distributing. So if I look at, this is on the screen, but I'm going to show it to you without calling. If I look at 20 x to the 6 plus 15x squared, DCF is common factor, I say to myself, what can I take out of both of those terms? So what can I divide out of 20 and 15? X squared. And what can I take out of the numbers in front? A 5. Now, some people can't see that you can take an x squared or x6 out unless they expand it. So you could do this as well. 20 and then you have 6 x's. X times x times x times x. Plus 15 times x times x. And you can say, how many x's can I take out? I take out 2, right? So I take these 2, pull them out, and then I still actually have 4 left. Okay? You're not dividing by 2 and getting 3 here. You're literally just taking 2 out. Okay? So I take 2 out of the 6 here, I'm left with 4 x's, and I take these 2 out, I'm not left with any. So I have a 5x squared in front, and now I say 20 divided by 5 is 4. X to the 6 divided by x squared. When you have common base with exponents, you subtract the exponents, right? So that's why we get x to the 4 and not x to the 3. You don't divide exponents when you have the same base. So x to the 6 divided by x to the 2 is x to the 4. People get it mixed up. If I had x to the 6 divided by 2, that would be x to the 2. But I have x to the 6 divided by x to the 2. And when you have same bases divided with exponents, you subtract. So that's very different. Okay, one base, you would actually divide. 2 bases, you subtract. And then we have a plus sign. 15 divided by 5 is 3. X squared divided by x squared, everyone tells me is 0. It's not. X squared divided by x squared, listen to this. They cancel. And when they cancel, they actually make a 1. This is a 1 when you cancel. Great time when you cancel, you can make every single one of those be a 1. It's a 1, it's not a 0. If it was a 0, it'd be 0 times 3 and it would cancel, or be 0. Right? When you divide 2 things that are the same, you're always left with a 1. In this case, it's not a big deal. However, if I had something like this, 3x squared plus 3, let's say, what could I take out of both of those? Just this 3, right? If I take a 3 out, 3x squared divided by 3 is x squared. Plus sign, what's 3 divided by 3? 1. You have to write the 1. People write zeros all the time. That would be the common error that would be on your diploma. That would be the most common picked error on your diploma. Is that something like this? Everyone drops it off. It doesn't go away. 3 divided by 3 isn't 0. You don't put a 0 back there. It's a 1. You have to write the 1. X squared plus 1 is the answer. What will be on the diploma? 3x squared. Because you'll forget to put the plus 0, right? And if you put the plus 0, it's still wrong. You have to put plus 1. Because 3 divided by 3 is 1. That's a common error that happens in GCS all the time. Okay. Let's look at these ones. Example 1. Factor. Whenever you're asked to factor, you must always check for GCS. That's the first thing you're going to do. You're going to check for GCS and different squares. Breaking up that's the only two things I can make you do. I can't make you do trinomial factors. Out of the scope. In the curriculum, it states to me that I can only make you factor monomials or binomials. Monomials is 1 term. Binomials is 2 terms. Trinomials is 3. That's where it's like what times what equals what? What plus what equals what? I can't do trinomials. It's not my curriculum. So, because it's not my curriculum, I can't do it. That's great. You can't be asked to. Alright? It's 20-1. Where else? Do it. So we have 25 d to the 5 plus 45 d to the 4. If you wanted to, you could write it like this: 25 and then 1, 2, 3, 4, 5. These little dots are just multiplication signs. I rarely use multiplication signs anymore because they look like X's. Okay, rare you'll be using dots too. And then plus 45. You do not need to write this out if you understand how to do it without this way. I'm just showing you 2 ways just in case you're like, I have no clue. So you can write all the D's out separately like that before, but if you can see that, hey, I can take 4 D's out of both of them without expanding it like that, don't. Okay? This is just another way if you can't see it. So, the two numbers in front, 25 and 45. What number can I take out of both of them? Divide evenly into it. Anyone know? 5. So I'm going to take a 5 out of both. How many D's can I take out of both of them? It's always the smallest exponent, so this is D5 and D4. D4 is the only one I can take out, because I can't take 5 out of 4 if you don't have 5. It's like giving you 4 apples and saying, give me 5. You'd be like, I can't, I only have 4, right? You always have to take the smallest amount out, so D4. So you can't take 5 out of 4. It's not possible. And showing by this, I can take this. That's only 4. I can't take more out of that. Okay? So, 25 divided by 5 is 5. D5 divided by D4, you can't divide them. Yes, you can. Remember, you're subtracting. So D5, and if I take out 4 D's, it's like having 5 D's equal 4 D's and left with 1 D. Plus sign. 45 divided by 5, 9. D4 divided by D4. What is that actually? D4 divided by D4. Not 0, it's 1. So I technically have 9 times 1. I'm just not going to write that. That is not intentional. Let's just get that. No, it's not work. Okay. We'll look at B and then you'll work on some together. Or by yourself. And then we'll work on them together. 9K4 plus 12K3 minus 6K. If you need to expand the K's out, go ahead. I'm not going to anymore, but if you need to expand it out, please do. Yeah, let's come to 9, 12, and 6. 3. So I can take a 3 out. And Riley, let's come into K4, K3, K. K4, K3, K. Just a K. Yeah. I can't take any more than a K out because it's not a K. What if this one was just minus 6 and there was no K? Can I take out K? If this one didn't have a K at all? You actually will take it out of all of them or none of them. Okay? So if this one doesn't have a K, I would just take a 3 out of all 3 of these terms, that's it. So 9 divided by 3 is 3. K4 divided by K, like having 4 K's, I take K1. That's K3. Plus sign. 12 divided by 3 is 4. K3 divided by K, K squared. Minus 6 divided by 3 is 2. K divided by K is 1, so I can try to get 2 times 1, so I'm not sure. You're going to do the rest. Some of them you can't make any better than they are. For example, F. 13A plus 20B. 13 and 20, 13 is a prime number. I can take nothing out of 13 and 20 divided into 2. And A and B, they don't have the same letters, right? This one is done. It's no better than that. So sometimes you can't take out these yet. That's the problem. There's one more on here that you can't try. So you try. So 8x squared plus 10x, you can take out a 2x. 8x squared divided by 2x is 4x plus 10 divided by 2 is 5. X divided by x, it cancels. D, I can take out a 4. You got a 2, not the end of the world. You have to go back out and take out on another. So you can take out a 4. 12 divided by 4 is 3. y stays. Can I take out a y because it doesn't have one? And then negative sign, 16 divided by 4, 4. So this should be basic math, you guys. Just getting your brain back into math. E, negative 15d to the 5 plus 45d to the 3. I would take a negative out. If my leading term or leading coefficient, the number in front of my first term, of the highest exponent, is negative, I usually pull it out. Sometimes you won't have to, but for the most part, 99% of the time, it's beneficial to take out. And you'll see why in action. We take a negative 15 if you didn't, not the end of the world. E to the 5, e to the 3, the biggest one you can take out is e to the 3. Negative 15 divided by negative 15, it's cancel. E to the 5 divided by e to the 3, you have 2 left, so e squared. You take a negative out of positive 45, actually changes the sign. So anytime you take a GCF out that's negative, every sign that you normally have is going to be opposite. Okay? So this is a negative 15d5, so it's positive d squared. It's a positive 45, so positive 45 divided by negative 15, you're actually left with negative 3. d cubed divided by d cubed cancels. That's it. X is going to be on the 2. G. I use G to show that you have to remember to put that 1. If you're someone who forgot the 1 again, make yourself a little note with the star and say, I'm doing this every time. I have to remember that when I take that value out of the exact same value, I must put a 1, not a 0. Okay? C cubed plus C squared minus C, I can take a C out. C cubed divided by C, C squared. Plus C squared divided by C is plus C. Minus C divided by C is negative 1. So C divided by C is a 1. If you put a 0 or you put nothing and you just let it go away, mix up a note and say stop doing that. This is what I do, and you stop doing it. Okay? It's a common error. And until you make your brain stop doing it, it's going to keep doing it. All right? H. 6n squared minus 30n plus 42. I can only take out 6. I can't take out n because 42 doesn't have one. If you took out a 2 or a 3, you realize after that you can take out a 2 or a 3 still. Okay? So it's always best to take out the biggest one. If you forget that you can take out the biggest one, you'll have to take out another one. So you choose that. Not the end of the world. So I take out a 6. So equal, that's an equal sign. It doesn't look like one, but 6. 6n squared divided by 6, n squared. And 30n divided by 6, 5n. Plus 42 divided by 6, 7. Not that. That trinomial, you can't factor it. You never will be able to factor the trinomials. Like, they won't make it that you can in that, because then it would force you to maybe be able to do it, and they won't. That is the score. I, nothing. You do nothing. Or, if you wanted to, I guess you could do something. You could pull a negative 1 out. Take a negative 1 out, and you'd be left with 7n squared plus n minus 17. When you take a negative 1 out, it basically changes all the signs. 18p minus 63p squared minus 9p. Again, you need light bulb. You can take out a 9 and a what? 18 divided by 9 is 2. P cubed divided by 2 is p squared. 63 divided by 9, 7. P squared divided by p, p. Minus 9 divided by 9, p is negative 9p divided by negative 9p is minus 9. It's smart to make you look like I have kindergarten handwriting. Okay. What do you guys want to say? Now, this is why I always say you have to check for GCFs first, because when we go over difference of squares next, you're going to look at this and you say, oh, it's not a difference of squares. This isn't a perfect square, neither is this. I can't take the square root of 50, it gives me a decimal. I can't take the square root of 18, it gives me a decimal, so this isn't a difference of squares. Actually, it is. Once we take the 2 out. So I don't expect that you went that far because you might not notice it, but you have to remember to always check for GCFs first. we take out a 2. 18 divided by 2 is 9x squared. Minus 50 divided by 2 is 25y squared. A difference of squares, remember, is when you have a binomial, so 2 terms, with a different sign, so subtract the sign between them, and the perfect squares. With a difference, subtract of squares, perfect squares. So if I look here and I go, the 2 is just going to carry down, because I'm not going to do anything with it, but I have to keep it coming with me. If I square root 9x squared, what's the square root of 9? 3, so that's good, it's not a decimal. If it was a decimal, this wouldn't be a difference of squares. Square root of 9 is 3. Square root of x squared is x. So both of these things have to be perfect squares. So if you square root of them, they can be decimals or partial x's or something. Square root of 25, y squared. Square root of 25 is 5. Y squared is y. You don't know where the square root button is on your calculator, it's the second x squared button. Okay? Press the second button and then the x squared button to see the square root. So, now you have 3x and 5y. When we factor, we get 2 brackets, right? What you do in fact. So we get 3x in the front of each bracket. And we get 5y in the back of each bracket. What sign should we get? Remember? One positive, one negative. Should we go positive first, then negative? Should we do negative first, then positive? Does it matter? All that matters there are have to be opposite signs. You can't have a plus, plus, or minus. And then you go positive, then I'm hoping for most of you this is just review. And now I can go to 25, z to the 5, that's the smallest z. 100 divided by 25 is 4. Z9 divided by Z5 is Z4. Plus 50 divided by 25 2. Z6 divided by Z5 is Z, or Z1. 1. I make my Z like this and start looking at 2. And then minus 75 divided by 25 3. Z5 divided by Z5 is 1. So it's great. Okay? Thanks for over. So this is that difference of squares. Step for this difference of squares. It just is decided the 2 terms. It's 4, I don't know what. Decide if the 2 terms have anything in common, called the greatest factor. So first thing we do for difference of squares, whenever you see 2 terms with a subtraction sign in front of it, you just think, hey, this is probably a difference of squares, or it could be, right? First thing you ask yourself is, can I take out a GCF? Second, is it a difference of squares? Okay? So can I take out anything from b squared minus 64? No. Then I say, is it a difference of squares? So you have a subtraction sign in front. Well, the only way I can tell is if I square root them and I don't get decimals. B squared divided by square root of b squared, sorry, is b. The square root of 64 is 8. So they both work out nice. They both work out nice, get 2 brackets. B goes in the front of both brackets. 8 goes in the back of both brackets. And a plus and minus sign. Now you might say, why did I put in a plus or minus sign? Remember that whenever you factor anything, you can actually, in grade 10 when you were factoring, you could have always, on all the types, unless they give you like partial things, you could have always worked them back and see if you were right. Because whenever you have factors, you can expand them back out to collect like terms and see if you get the question, right? Same thing here. B times B, B squared. Minus 8B plus 8B, they cancel, right? You get 0 B's. That's why you have to do opposite signs, so you don't get that middle term. And then 8 times -3 is -64. If I expand this, I get this back. I'm right. So in grade 10, you could have walked away from your factoring something like I-80 stepping or blue with that. If you could distribute back in your answers, you could get your question, right? You can do that always too. Check your factoring on your test. 8 squared minus 144. 2 terms, subtract the sign in between, so possible difference of squares. First thing I ask, can I take anything out of both those terms? No. And I check and see if it's two differences. Square root of a squared, a square root of 144, 12. So there's two brackets. A goes in the front, 12 goes to the back, negative, positive, or positive, negative, it doesn't matter. Got it. You guys try the bottom one. First thing I ask myself, can I take something out? No. Square root of 9a squared is 3a. Square root of 121 is 11. Then I get 3a in the front of these brackets. And that's that. Plus and minus. X squared minus 81. Square root of x squared is x. Square root of 81 is 9. And you get x plus 9, x minus. 324a squared minus 289. Square root of 324 at 18. Okay. 289 is at 16. 17. Oh. 206. What's 16 squared? I don't know. Okay. Square root, so we're going to get 18a plus 17, 18a minus. Now, 81 minus n squared, there's nothing wrong if you go 9 minus n, 9 plus n, but often, when you're in chemical rationals, you're going to have a variable first, so there's n plus I and minus I, right? So what I like to do is I like to write the variable first. So if you did it as 9 minus n, 9 plus n, you're not incorrect. And I'm going to tell you what I do. So I like going negative n squared plus 81. 99% of the time, this is better. There's that 1% where they have them backwards. Then I take a negative 1 out. And I get n squared minus 81. And then I'm going to get negative 1 and plus 9 and minus 9. And why would I want to do that? Because normally the other factors in the rational, which doesn't exist right now, but trust me, usually the other factors that you're going to want to cancel off are n plus n and minus, not 9 minus n, 9 plus n. If you did it the other way, that's fine. You're going to have 9 minus n, 9 plus n, which is okay. But then I rewrite them. So I could go negative n, you can take the sign that's in front of it with it. Negative n plus 9, and this would be n plus 9. And then you could just take a negative 1 out of this bracket, and you get n minus 9, n plus 9. You could have done it that way as well. Both of these are correct. This one some people don't actually spot because they don't see that the 1 is a perfect square. 1 is always a perfect square. And I don't know why, but this one gets like not picked up a lot. Here, there's a 1. 25x squared is 5x. Square root of 1 is 1. And then you get 5x plus 1, 5x minus. Then h, you could have done 2x plus 6, 2x minus 6, but then you'll notice that you can take a 2 out of both of them. Like the form cut. And notice that you have to. You have to notice you pull a 2 out of both those, 2 times 2 gives you a form cut. Or what could you do, like I told you to do always, check if there's a GCF. There is. You can take a 4 out of both of these. So you get 4x squared minus 9. Then this is the difference of squares. X, 3, then you get 4, x plus 3, x minus 3. Now, like I said, what if you forget to check for GCF? You would have gotten 2x plus 6, 2x minus 6, and then you would have to spot, hey, I can take a 2 out of here. So I get 2x plus 3. Hey, I can take 2 out of here. 2x minus 3. Now these, because they're all in brackets, are actually all multiplied together. 2 times x plus 3 times 2 times do GCF every single time, check for GCF first every single time. We'll do the extra steps. Okay, that was our review. Then we start rationals. Rationals, if you were to tell you that's when you did rationals, but you did it this time only if you made it a little harder. The rational expression is when you have like something is a variable over something is a variable. So like for example, x plus 3 over x minus 2. It could just be a number over it. So it could be like or 7 over x or x over 7. Anything like that is a rational expression. Do you remember why we have non-permissible values or restrictions? Non-permissible values and PVs, so you're going to say NVPs, I think just NVP, you can mix up. NPVs or restrictions are just words that mean the same thing. So on the diploma, if they say state the restrictions, or they say state the NP non-permissible values, the same thing. Those words are interchangeable. Do you know why we state non-permissible values on rationals? Anyone remember? Everyone grab your calculator for a second. In your calculator, go 0 divided by 9. Then you get 0 divided by 9. There we go. 0. Now go 9 divided by 0. With your calculator. What do you get? Error. Rules from little on, you can't divide by 0. You can go 0 divided by something is 0, but you cannot divide by 0. It's natural. It's like this. Your calculator doesn't do that, right? So, when you did fractions in grade, I don't know, 7, 8, 9, 6, I don't remember when you start. When you do fractions in those lower grades, you don't have variables. You don't have letters, right? So you never had to state restrictions because your fraction denominator was 7 or 3 or 5. It wasn't 0, right? The other time they'd test you and say, what are the answers to these? They go 7 divided by 0, and you'd have to say error or something like that just to see if you remember the rules. But with rationals, we have variables. We have letters. So we have to state restrictions because we have to state what that letter can't be. Because if it was that, it would make that denominator be 0. And can we have 0 in our denominator? No. Our calculator's even told us that. So we're stating restrictions and non-permissible values because we have variables, letters, in the denominator. And once you have a letter in the denominator, you have to tell what that letter can't be, because if it is that number, the denominator becomes 0 and the whole question is thrown out. That's why we see the NPV, not because you just know how to find it. That is the reason why we do it. Okay? So for this question here, x plus 3 over x minus 2, I don't care about the numerator, because the numerator could be 0, right? The top, it can be 0. We showed that. That's fine. It's just the bottom that can't be 0. So there's an x value in the world here that can't exist, because if it did exist, this question would be thrown out. The denominator would be 0. This is a really easy one to see. So what can't x be if it was? This whole thing would be 0. 2. If x was 2, this would be 0. We'd be wrong. We'd be done. So the non-permissible value or the restriction on the variable, the restriction means you're restricting that variable to something, right? It can't be everything. The moment your variable can't be everything, you have to say a non-permissible value for it, so a value it can't be, or a restriction on that variable. That's why the words can be changed interchangeable. They mean the same thing. So we're going to say x can't equal 2. And we've restricted our variable to everything else, but 2. And we solve rationals, which if you return x, you did. When you solve a rational, you're finding out what x can be. If I solved the rational, it has to have an equal sign in the question, right? But if I solved it, and it told me x is 2, and my non-permissible value told me it can't be 2, then I actually have no solution. The answer is no that. Great that you got that. What if you don't check for non-permissible values? Well, then you're going to circle 2 on the diploma, and you're going to get it wrong. Because your non-permissible value said it couldn't, but you have to check. Okay? So non-permissible values is extremely important. So, the first thing we want to do when we want to find non-permissible values or restrictions is factor that denominator. We only care about the denominator because the numerator can be 0. We don't care. 0 divided by something gave us 0. That works. Just the denominator, the bottom. So we factor it, great common factor, or difference of squares the denominator, and then we set each of the separate denominators in brackets equal to 0, not equal to 0, and solve for that variable. Find out what it can't be. Okay? So for this question here, example 1, consider the rational expression x plus 1 over 5x squared minus 5x. A, determine the non-permissible values of that rational expression. Okay. Do I care about the numerator at all? If I'm just asking for non-permissible values. No, I don't care about the denominator. First step, that is a funky looking denominator. So I'm going to try and GCF it or factor. Remember the only factoring you can do? Difference of squares. So don't spend time trying to go what times what between what plus what between what. You waste your time. I can't even give you questions like that. If I do, you could say it's no less, you're not allowed to, and I have to get off the test. Okay? So we have 5x squared minus 5x. So what can I take out? A 5x. This is the catch. If you make the GCF wrong, you're not going to get the B's right. So I take the 5x out. 5x squared divided by 5x, and left with an x. What's negative 5x divided by 5x? 1. If you say 0, you're getting into 0. So the basic GCF, which is super easy, if you make a stupid mistake on it, you're going to get all of the questions wrong, right? So you need to know your basics really well, or it doesn't matter how well you know the rest of the steps. I know some students who pick up on all the new stuff in 30-2 really well, but their basic old math skills are not very good. They said, I haven't done my homework for like 2 years, but I started trying this year. That's what they say to me. You need to get caught up on those basic skills because it doesn't matter that you get my new ones. If you can't do the basic ones, you're not going to get the answers correct even if you're doing the steps. Okay? If you need help with stuff, make sure you come in and get help on the basic stuff. Even if it's, you think, oh, I can't tell, I don't have a GCF. You can. You look more foolish when you get every answer wrong. It looks way better when you just ask, I can't do GCF, I have no clue. Okay? Please don't feel foolish. Come in and ask us. So negative 5x divided by 5x is minus 1. Okay? Now, I've said this before if you're in my 20x1 classes. If anything is attached by a plus or minus sign, you have to have its own bracket. So this x minus 1, I always don't put in its own bracket because it's attached by a plus or minus sign. It's attached, it's like those things are sewn together. So you have to bracket around it. Anything that's not sewn together goes in its own bracket. So this 5 and x, does it have a plus or minus sign in between it? No, so it can go, each of them can go in their own bracket. They're not attached together. They're just multiplied together. Remember, you can say multiplication with an x, like a times sign. You can say multiplication with a dot. Multiplication with a dot. You can also say multiplication when you put brackets side by side to each other. That when they're attached to the brackets, that's a multiplication too. So this is multiplied by this. That's why I can put them in their own bracket, right? Instead of having no dots. Now, anything that is in its own bracket, I set not equal to 0. So 5 is not equal to 0, because it can't be equal to 0. Because if these are all multiplied together, if any one of these is a 0, my denominator is 0, right? Like if this is 0, you know, it's 5. 0 times anything makes my denominator 0. If this is a 0, this times 0 is 0. If this is a 0, it makes the whole denominator 0, because they're all multiplied together, right? So I have to do these separately. So 5 can't be 0, x can't equal 0, and x minus 1 can't equal 0. If any of those three equals 0, my denominator will be 0, and I'm going to have an issue. Do I have to write 5 can't equal 0? No, 5 can't equal 0. So I just did that proof point. You don't have to do this. It's not a non-predictable value. 5 can't be 0. Okay, that's never going to give us an issue, because this can't be 0. These two, however, if they turn to 0, we have issues. So, x can't be 0. True. Yeah. X minus 1 can't equal 0. In order for it to have its own value, we have to have it as x can't equal something. So this one we're not done. We still have a step left. We can add that 1 over here. So I'm going to add 1 to 2 over. And x can't equal 1. So what are my NPEs? X can't equal 0, comma 1. You can put them together like this. Now, just like in grade 10, I told you you could have checked your factor. You could have expanded your factors that you got and saw if you got your question back again, right? Same thing here. You can check the non-permissible value. Take each one separately and plug it in and see if you get a 0 in the denominator. So I take this 0, and I plug it in. 5 times 0 squared is 0. Minus 5 times 0, 0. What 0 is minus 0? 0. So that 0 would get me a 0 in the denominator, so it's good. Then I check the 1. 5 times 1 squared, 5. Minus 5 times 1, 5. What's 5 minus 5? 0. So 1 got me a 0 as well. Good. Done. I can walk into this next and be like, I'm a genius. So if you're stuck on a diploma and you're like, oh, I'm going to have the IT. Trust me, you won't, because it'll be built in your head for the next 8 years. Keep repeating. All these questions will come popping up on your little daily quizzes so that by the time January comes, you've seen NTVs, well, a billion times. But say you blank, and it's a multiple choice question, and they give you the NTVs, the multiple choice, because you plug them back in and see what works. Which one makes you do? Yes. You can work your multiple choice back. On your diploma, you have 40 questions. 28 of them are multiple choice, 12 of them are numeric response. You do not have a written whatsoever. On your unit test, you will have written, because it's not good practice to not have written. It's just that the government doesn't want to pay teachers that much. So we have 28 multiple choice, 12 numeric response on the diploma, but on your unit test, you have some written response as well. It's not good practice to not have written. It's just that they want to save money. Science, all the sciences will save, and math. Written on the diploma. 12 numeric response means you can't plug answers in, right? You're just filling into a little box. So that's why numeric response will find a little harder, because they can't work backwards. There's no answer to work. Now B is a really easy question since we've done A. B says state the restrictions on the variable. X can equal 0 or 1. That's it. This means the same as this. My point here is they are the exact same. We can just say it in 2 different ways. Okay? You guys try A, B, C, and D. We'll go through them right away. Try them. So for this one, I say, can I think of a GCF in the denominator? Have a denominator, say minus 1. No. Can I do difference to square? No. They're attached by minus signs, so they're going to be in their own brackets, right? That's the only one I have. And anything that's in its own brackets after this step, I set not equal to 0. So I'm going to have A minus 1 times equals 0. And I'm going to add 1. A times equals 1. You could have also just looked at this one and said, hey, what could A not be that would make it 0? Now B, I can't go straight right ahead and go 2k squared minus k can equal 0, because I can take a k out of it. So you take a GCF out, or a squared, and do that first. So for this one, I can take a k out. Do I care that the numerator is a 4 or a 7 or a k or a smiley face? It doesn't matter what the top is when I ask for just NTV. Okay? So 2k squared minus k. I ask myself first. GCF, difference of squares. So I can take out a k. And then I'm left with 2k minus what? 1. The 2k minus 1 has to be in its own brackets. It's attached by subtraction sign, right? And the k can be in its own bracket. So I'm going to get 1, 2 non-principal values. Done. So I take this k, and it's not equal to 0. Take the 2k minus 1, and it's not equal to 0. Take the k, not equal to 0. 2k minus 1, not equal to 0. K not equal to 0 done, right? This is already k by itself. So I already have one in TV. The second one I have to solve. 2k minus 1 is not equal to 0. I need to solve for k. What's the first thing I have to move? The 2 or the minus 1? The minus 1. How do I move minus 1 from what that's good? Yeah. You get the k by itself. The 2 is being multiplied by the k. How do I get rid of multiplication? Yeah. And divide both sides by 2. For those of you who choose to skip this step, it's scary how many people Rewrite this and they're like, oh, you can divide by 2 in the head. And then they write this as 2 over 1 instead of 1 over 2. Happens a lot. So if you just use division by 2 like this and divide by 2, it causes that error to go away. People just write it this, I don't know why, but I'm flipping it so you can just flip it. I don't know why. So I always go divide by 2 cancel it, divide by 2, and k can't equal a half. And then I always put them together. So I say here, k cannot equal 0 or a half. Try C and D. C, hint, GCF. E, hint, difference of squares. So, 2n plus 10. I can take a 2 out, and then like this n plus 5. Now, I don't usually see this on unit tests, because by the time unit test comes, you've already kind of gotten rid of this error. But it does happen on the first few quizzes I give you. People will tell me, okay, n plus 5, you're going to do that. You're like, n plus 5 can't equal 0, n plus 5, and can't equal negative 5. Everyone does that. But then people tell me n can't equal 0 as well. Actually, let me plug the 0 back in. 2 times 0 is 0 plus 10. What's 0 plus 10? 10. Does 0 cause me to have 0 in the denominator? No, so 0 actually isn't an NP. This number 2 in front, it's in its own brackets. Can 2 ever be 0? The only time you create yourself an NPV is if there is a variable, a letter, right? 2 is by itself. 2 doesn't have a letter on it. So 2 doesn't equal 0. Now, however, had it been like this, and then n plus 5, then n wouldn't be able to equal negative 5, and n wouldn't be able to equal 0. This is true. This would make n not be able to equal 0. But if there's a number in front, this 2 can't be 0. It won't cause me an NPV. So the only NPV for this question is n can't equal negative 5. The 2 isn't going to cause me. It doesn't have variables. So that's an error for now. Usually that error we don't know by the time you get test comes. So for the first few quizzes, you guys put 0 all. Okay. This is the difference of squares. So I get x plus 7, x minus 7. So x plus 7 can't equal 0. X minus 7 can't equal 0. X can't equal negative 7, you move the 7 over. X can't equal positive 7, you move the 7 over. So you get x can't equal plus or minus 7. That's usually how quick numbers are formed on test. They put the positive negative in front and only write the 7 1. So it's usually like that, plus or minus. Okay? If you wrote positive 7 and negative 7 on the test, you're going to pop out of the field. Right? I just want you to know that this represents the same thing. Okay? Flip over. This one I can take a negative 2 out. If I take a negative 2 out of negative 2x, I'm left with a positive x. If I take negative 2 out of negative 4, I'm actually left with a plus 2. Does this negative 2 get me an NPV? No, it doesn't have a variable attached to it. So that's golden. I need to x plus 2 can't equal 0. So x can't equal negative 2 when you subtract it. That's the only NPV. A squared minus 81 is the difference of squares. Square root of a squared is a. Square root of 81 is 9. You're going to get a plus 9, a minus 9. You get a plus 9 can't equal 0. A minus 9 can't equal 0. Subtract 9. A can't equal negative 9. Add the 9. A can't equal 9. You get a can't equal positive or negative. D is a trick. So you're kind of stuck on D or you got yourself a really good answer. All right, D is tricky. C, you can take a P out, and you're left with 4P minus 1. Minus P, I know people are a better chance at. If I put a plus P back here, the chance of me getting a plus 1 is about 50-50. Everyone drops it off. Okay, so don't be that person. Minus 1, they usually keep it. Plus 1, it vanishes. So I'll do that. So here we're going to get p can't equal 0, and we're going to get 4p minus 1. This one's done. So we're going to keep that stuff. So I'm going to add 1. I get 4p can't equal 1. Divided by 4. Okay, these other formulas. P can't equal quarter. So p can't equal 0 and a quarter. D is tricky. You can pull the 2 out and think, hey, I have different squares. What's the key to difference of squares? Difference. What does difference mean? Fraction. Do you have subtract sign? No, not difference. You take the 2 out and you're left with x squared plus 4. Can't factor that. Find difference of squares. So all you can do is try and solve it. 2 can't be 0, so we don't have to worry about that. If you go x squared plus 4 can't equal 0, you get x squared can't equal negative 4. When you take the square root of anything, you take the plus or minus of it. So I'm going to get positive negative of negative 4. Negative 4. What's the square root of a negative number? Good question. The square root of negative 4 in your calculator, it's going to error you. You can't keep the square root of a negative number. There are no NPVs. This is tricky because, let's look at this. I'm trying to figure out where x squared plus 4 can get me a 0, correct? The only way that I can get x squared plus 4 to get me a 0 is if I can make this x squared be negative 4. So negative 4 plus 4 is 0. We agree? Is there any number in the world that you can square that will get you negative 4? It's a negative 2. What's negative 2 squared? Positive 4. So you square something, you're going negative 2 times negative 2, which is positive 4. There is nothing you can square that will stay negative. Any number in the world that you square turns positive. Because a negative times a negative is a positive. Anyway, well, my calculator is totally different. Your calculator, if you go negative 2 squared like this, it will tell you it's negative 4. It's wrong. Remember, your calculator isn't a human. It can't read your mind. Your calculator reads negative 2 squared. It reads it like, you type it in like this, your calculator thinks you're doing this. So it keeps it negative. If you want to square any negative number, you guys, you have to go bracket negative 2 squared. That is the only way that your calculator realizes that you're squaring negative 2. If you go negative 2 squared, your calculator thinks you're going negative 2 squared. 2 squared is 4, but the negative in front is negative 4. That's not what you're trying to do. That's what your calculator thinks you're doing. If you want to square a negative number, you have to put it in brackets, so your calculator every time will tell you it is negative. And any number you square is positive. I don't care what number you do. Because a negative times a negative is a positive, and a positive times a positive is a positive. Anything you square a number, you're squaring that same number, and then you multiply that same number twice, then you get a positive. Don't let your calculator make you believe you're wrong. Okay?